Hi friends, welcome to this class on the acid-base salt chapter, and in this video we'll be focused on the acids part, and I'm going to make the concepts really easy for you, so I'm sure you'll really understand what acids are. I'm going to show you the tips and tricks on how to write the reactions and how to predict the reactions for the acids, so you'll find the topic really easy. So hi, I see a lot of folks are here on the chat. So thanks for joining in on this live session on the acids topic. So I see Madhu is here, Binita, hi. Hi Srinivas, hi Yash Gaming, hi Gamer Galaxy, hi Arjun Singh, hi Arun Ahmed, hi Rahul Dar. So sorry if I can't take everybody's names. Hi Shauman Mukherjee, hi Gautam Devnath. So welcome to this class on the acids, bases and salts chapter, and we are going to be focusing on acids here. And guys, you can check out my website manochaacademy.com. So we have courses here, and we are excited to let you know that we've also launched the ICSE Class 9 course. So if you're on the ICSE board, do check out the physics course for Class 9. So we have these different courses on the website for you to check out, and they have videos, quizzes and questions, and I'm sure you'll find them really useful. So hi Venu, hi Upendra Singh, hi Guru Darshan, hi Maya. So good evening, welcome to this class, and let's get started with the acids topic. So I'm going to make the concepts really easy, and be sure to watch the entire class. I'm sure you'll enjoy it. So let's start with acids in everyday life. So you must be familiar that we are using or we come across acids in our daily lives. So I have an interesting question here for you, where you need to match the pictures with the acid list that is given here. So can you see that there's a list of acids given right here, okay? And you need to match the pictures with the acids. And guys, if you haven't hit the like button, do hit it right now, and also subscribe to our YouTube channel manochaacademy.com and click on the notification bell so that you get notified about the new videos. Alright guys, so let's go ahead and start with this one. So let's start with the first picture. So here can you see that there are oranges in this picture, okay? So which acid is present in the orange? So let's go picture by picture. I can see a lot of good answers coming on the chat. So let's go one by one. So let's start with the orange right here, okay? Can you see that? So what acid is present in the orange? Excellent, I see the right answer on the chat. So you guys got it. The main acid is citric acid, right? And you know orange contains vitamin C, which is ascorbic acid, but we are matching the ones on the list here. Excellent. Now let's go on to the next picture. So can you see this picture of a soda, right? So a soda drink here. So can you tell me what is the acid present in soda? Okay, so from this list here, what is the acid present? Super, you guys are great. You've got this one too. So the acid is carbonic acid. Excellent answer. So when you're drinking a soda, you're actually consuming carbonic acid. Next, let's move on to the next picture here. Can you see the picture shows a bowl of vinegar, right? They poured vinegar from here. And what is the acid present in vinegar? So guys, can you tell me this one? Okay, excellent. I see the right answer. It's acetic acid. Okay, so that's the correct answer. So let's go ahead and tick the ones that we've used. So we've used acetic acid here. We've used citric acid, and carbonic acid was present in the cola drinks, right? Now let's go ahead to the next one. Can you see this bowl of curd, or what we call yogurt, right? So in this bowl of curd or yogurt, what is the acid present? Super, that's the right answer. The correct answer is lactic acid. Okay, so absolutely right, and let's take that one too. Now next, what is the acid present in tomatoes? So who can answer this one for me? So what is the acid present in tomatoes? Okay, so I see a lot of you are writing the correct answer, oxalic acid. Absolutely right. So tomatoes also contain citric acid, but it also contains oxalic acid. So we are trying to choose a unique one from the list, since we've already used citric acid. So oxalic acid is the perfect answer. Next is the picture of a stomach here. And as you know, our stomach produces acid, and that acid helps in the digestion of food. Okay, so guys, and I see some of you have written malic acid. That's also true. Tomatoes do contain an amount of malic acid also, but we are choosing from the list given here, right? So guys, what is the main acid present in the stomach? Excellent, I see the correct answer. So the answer is hydrochloric acid. Perfect. So you guys are awesome. You know all the acids in your everyday life. And guys, this last picture, can you see the ants there, right? So you know that when the ant bites, okay, the bite of the ant stings us, and that's because it injects some acid in us, right? Absolutely correct, and that's the answer is formic acid, because I think in Latin ants are called formica, right? So it's based on the Latin word. So ants, the sting of ants contain formic acid. Superb, excellent answers. You guys really know your acids. So and if you haven't got some of these, do learn it up, because it's important to know which is the main acid present in these things. Okay, now let's go on to this question. So as you can see here, we've got that matter can be classified based on its chemical properties. So here we have classified matter based on chemical properties. Okay, and so based on chemical properties, we can divide matter into pure substance or mixtures, right? And pure substances further can be divided into elements and compounds, and mixtures can be divided as homogeneous or heterogeneous mixtures. So now the question is, in which category out of all of these that you see here are the acids in? Since we are talking about acids here, right? So where do you think acid falls in these in this chart? Okay, so some of you are saying pure substances, some are saying elements. Where do you think I should put acids here? Homogeneous. Okay, so think carefully. This is very important. You should know which category. So by category I mean the four at the bottom, right? So is acid an element or a compound, right, which is under the pure substances, or is it a homogeneous mixture or heterogeneous mixture? And here we are talking of the pure acid, not mixed with anything, right? So what do you think is the correct answer here? So absolutely right. Acids fall under the category of compounds, okay? And in fact, this chapter which is on acids, bases and salts, all of these guys, acid, bases and salts, they are all examples of compounds, because these contain more than one element, okay? So absolutely right, compounds is the answer, and we are going to focus on acids in this video, okay? But remember, they are under compounds, which is under their pure substances. Excellent. So now since we talked about acids here, right, we can which came under the compounds category, we can further classify acids into these two categories. So can you see, guys, it can be inorganic or mineral acids and organic acids, okay? And we are going to talk about what these terms mean. So acids can be divided as inorganic or organic, and inorganic, another word is mineral acids, okay? So what is the definition of mineral or inorganic acids? These are the acids that are prepared from the minerals of the earth, okay? So they're found on the earth's crust, or they're prepared from those minerals, and these acids are usually dangerous, okay? So most of the mineral acids are usually dangerous, and they need to be handled with care. All right, and here I have some examples of mineral acids for you. So let's take a look at this acid. The first one is hydrochloric acid, right? So hydrochloric acid, can you tell me what is the formula of hydrochloric acid? So let's write down these formulas, because you need to know them in this chapter. Excellent. It's HCl, right? Hydrochloric acid is HCl because it's made of hydrogen and chlorine, and you guys know that valency of hydrogen is 1, chlorine is 1. So to form the compound, since acids are compound, you do the crisscross, you're going to get HCl. Okay, right? And the next one, yes, someone is saying that HCl is present in the stomach. So yes, these are general classifications. So it doesn't mean it can only be found on the minerals of the earth. We know that HCl is produced in our stomach as well. But this classification of inorganic, organic is a rough one. But primarily it can be obtained from the minerals. Okay. What about sulfuric acid? What is the formula? So very good. The correct answer is H2SO4. So how do we know that? Because it's made of hydrogen and sulfate. And sulfate has the valency 2, so it's H2SO4, not HSO4. Okay. Next guy, what is the formula of nitric acid, which is also a mineral acid or inorganic acid? Very good. It's HNO3. It's made of hydrogen and nitrate. Okay. And what is the formula of the acid that is found in the sodas, right? In the colas, the carbonic acid. What is the formula? Very good. You guys are good. It's not HCO3, it's H2CO3. Okay. And how will you remember that? Because guys, you need to learn your valency. Okay. So what is H2CO3? It's why is it? Because hydrogen has a valency 1, carbonate has a valency 2. Okay. It's the carbonate ion. You know, it's 2 minus, right? So if you do crisscross, you're going to get H2CO3. So remember these important formulas. And remember, we said acid can be divided into mineral or inorganic and organic. So we talked about the first category. Now let's look at organic acids. So organic acids are called organic because, as you can know from the name organic, that these are obtained from living things. So they can be obtained from living things. Again, as I told, it's a rough classification. So some of you are asking me, when do I when do I have these live sessions? It's usually at 8 p.m. and I'm trying to take it every day. You know, I didn't take one on Sunday, but rest of the days I'm trying to have a live session every day. So guys, do subscribe to our channel and click on the notification bell so that you get notified about these live sessions and any new videos we upload. And do remember to share it out with your friends. Okay, so let's take a look at these organic acids. So ants, as we said, the sting of ants contain formic acid. So do you guys know what is the formula? So what is the formula for formic acid? Does anybody know? Okay, the formula for organic acid, for formic acid is HCOOH. Okay, and this is going to come, so good, I see some of the answers, and you're going to be seeing this in the organic chemistry chapter, the chapter on carbon and its compounds. Now the next one, vinegar, acetic acid. Do you know what is the formula of acetic acid? So this one is going to be, it's very similar to the first one, except instead of hydrogen, it's CH3COH. Okay, so the vinegar that we eat, it contains acetic acid, right? And the next one, oxalic acid, the ones that's present in tomatoes. So very good, I see a lot of you know the formula. Excellent. And what is the formula of oxalic acid? So you can remember it in an easy way. It's COOH whole twice, right? So if you work that out, that's going to be C2O4H2. Okay, but easier way to remember that is COOH whole twice. Now one interesting thing you'll notice that these organic acids, they contain the COOH group. These are known as carboxylic acids. Okay, and you'll be learning more about this in the chapter on organic chemistry, or some of you may be knowing this already. So the carboxylic group is called the COOH, and the organic acids, they must contain carbon, and not only carbon, they contain the COOH. All right. Now we talked about classifying them as mineral, inorganic or organic acids. Here's another way to classify acids. We can classify based on their strength. Okay, so here you can see we've classified based on the strength of the acid. So we can say, is it a strong acid or a weak acid, right? And usually the examples of strong acids are, as you can see here, the HCl, hydrochloric acid, sulfuric acid, HNO3, nitric acid. These are good examples of strong acids, and they are usually the mineral acids. So strong acids are usually mineral acids, but there are exceptions in chemistry. There can be mineral acids that are weak. Now let's look at the weak acid examples. So the weak acids are citric acid, acetic acid, oxalic acid. So they are usually organic acids. So what does weak mean and what does strong mean? Strong means they are highly corrosive. These acids are dangerous, right? So the strong acids are usually dangerous because they have a really strong and corrosive nature. And the weak acids are not so dangerous. In fact, we eat the weak acid, right? So when you eat a lemon, right, you're eating the citric acid, right? Or when you're having vinegar, you're having the acetic acid. Okay, of course you shouldn't have too much of it, right? Then you're taking in a lot of acid, but it is weak in nature. Okay, and our body can take it, we digest it. So usually the organic acids are weak acids and mineral acids are strong acids. Now, can you tell me of an exception? Like for example, if we take carbonic acid, right? So the carbonic acid that we talked about, H2CO3, which category do you think it will fall in? So would you put it under strong acid or weak acid? Guys, what do you think? Where should I put carbonic acid? So what do you think is the answer, guys? So carbonic acid, which I told you is present in the sodas, right? In the drink, the soda drink. So good. So the answer is it's a weak acid. And you can remember that because when you drink the colas or the sodas, you are able to drink the acid, right? So it's definitely not a strong acid. So that's an easy way to remember that the carbonic acid falls under weak acids. Okay. So it is carbonic acid is a weak acid, but it is a mineral acid. So it is an exception. So carbonic acid is actually a mineral acid, but as you can see, it's a weak. So the weak acid. So this classification that strong acids is usually mineral and weak acids are usually organic, right? So there's the word usually. There can be exceptions there. Okay. Now here's another interesting question for you. So you might have heard these terms, or when you go to the chemistry lab, you hear these terms, right? There's dilute acids and concentrated acid. So can you tell me what is the difference between concentrated and dilute acid? Okay, guys. So can you tell me what is the difference between concentrated and dilute acid? So here's the first question. Right? So what is the difference between concentrated and dilute acid? So we know that the concentrated acid basically has less water, right? Or no water, right? So usually it has less water, and when you add water to it, you get the dilute acid, and on mixing this, it generates heat. Okay. So what is dilute acid? Dilute acid is simple. It contains more water, less acid. Okay. So the meaning of dilute acid is there's more water and less acid, right? And concentrated acid is the opposite, more acid, less water. Okay, simple. And so how do we go from concentrated to dilute acid? Very simple. We need to add water, as you can see in the equation here, right? So to go from concentrated to dilute, you just add water. Now the interesting thing is, how should you dilute an acid? So here I have this question. So here are the three options. Should you add water to the acid? Should you add acid to the water? Or it doesn't really matter? So what do you think is the correct answer here? Okay, some of you are saying A, some of you are saying B. So guys, what do you think? So when you dilute an acid, right, what should we do? Add, so let's say this is our beaker here. Okay, so should we be adding acid to the water or water to the acid, or it doesn't matter? The correct answer is B. Okay, and we'll understand why. So let's say we are taking a beaker full of water and we are going to be pouring the acid into it. Okay, let's say this is the acid. So the acid is going to be gently poured into it, and we are going to be stirring this beaker constantly with the help of a stirrer here, right? And why do we do that? Because if you look at the equation on top, the important thing is this is an exothermic reaction. It produces a lot of heat. Okay, so if you add water to the acid, so if we did the first option, which is not the correct answer, if we did this option, then the dangerous thing is, because if there's a lot of heat produced, if this beaker contained a lot of acid, that acid can spurt out. Okay, because a lot of heat is generated, so the acid is going to spurt out, and it may hit your face or your hands, so that's dangerous. But if you add acid to the water slowly, water has this property of absorbing the heat easily. It has a high heat capacity, so the water can easily absorb the heat, and the heat gets distributed in the water because we are stirring it, so it's less dangerous. So guys, this is a very important question. It comes in the exam a lot. So you should dilute an acid by adding acid to the water gently. Okay guys, so please remember this really important point. Excellent. Now let's move on to the properties of acids. So the first question is pretty easy. I'm sure you know it. What is the taste of the acid? So what should I write here? So acids have a dash taste. What taste? Excellent. I see the right answer here. So you know acids have a sour taste, because when you taste lemon, you taste an orange, it has a sour taste because these contain citric acid. So of course there are these mineral acids or dangerous acids which you should never taste because they are highly dangerous. They will burn your tongue. But general, we say the acids have a sour taste. Okay, very good. Now let's talk about the next point, the litmus test. So when you do a litmus test on acids, does the red litmus turn blue or the blue litmus turn red, or is there no change? What do you think is the answer here? Okay, so what is the answer here? So very good, I'm seeing the correct answer. The litmus test is the blue litmus turns to red for acids. Okay, so as you guys know, the blue litmus turns to red. Excellent, that's the right answer. Please remember, so litmus test is a good test. We should not make taste a test for the acids, right? Because the acid can be dangerous. So you don't want to taste it. When they say how do you test an acid, a good way is to do the litmus test. Now let's take a look at the next question. So we've done the first 2 points. What about this question? Do acid solutions conduct electricity? Yes or no? What do you think? Okay, I see some yeses out there. Yes, they conduct. No, what do you think is the answer? The answer here, very good. The correct answer is yes. So acid solutions are good conductor of electricity, and there's a term in science for that. They are known as electrolytes because they are good conductors. So you can learn this term. Acid solutions, they conduct electricity. So acid solution means acid mixed in water, and we'll see why they are good conductors later on in this class. Excellent. Let's move on to the next properties of the acids. So as we discussed, acids are highly corrosive in nature, right? They're very dangerous. They can cause severe burns on the skin. So in the lab, we should be really careful. We should not be casual with when handling acids, whether they are dilute or concentrated, because they can be really corrosive and cause burn on the skins. Okay. And now I have this question here for you, that acid containers, right? So where is acid? The acid containers are usually made of what material? So what material is used to store acid? And here are our options. A is plastic, B is tin, C is glass, and D is iron. So guys, what do you think? And hint is, think about your school lab. So what material is usually used to store the acids? Excellent, you guys are awesome. That's the right answer, glass, because glass is very resistant to corrosion, right? So it is very resistant to corrosion, and it's an excellent material used to store the acids. And that's why acid bottles are usually made of glass. Of course, you get acid bottles made of plastic also, but that's not a good choice, right? Usually because plastic is cheaper, that's why they do that. Glass is the best choice because it's very corrosion resistant. Excellent. Now let's talk about the important chemical properties of acids. So this is one very important property which says that acids react with metals to form or produce hydrogen gas. So if we write it in equation form, we can say metal plus an acid. So metal reacts with the acid to form a salt and hydrogen. So let's look at this with the help of an example. So let's say we react the zinc, you know zinc is a metal, Zn, with H2SO4. What acid is this? Sulfuric acid. Okay. And so what do you think is going to happen? So we are going to get, so what do you think I should write here? So go ahead and try it yourself. Very good. I see the right answer. You guys have got it. It's zinc sulfate plus hydrogen. Okay. And this is hydrogen gas. Sometimes we mark it with up arrow because the gas is produced. Okay. So zinc plus sulfuric acid gives zinc sulfate. So this is our salt here. Okay. So that's our salt and hydrogen, right? And salt is formed of this cation zinc and sulfate anion, right? So can you tell me what type of reaction is this? So how can we predict that zinc plus dilute sulfuric acid is going to give us zinc sulfate plus hydrogen? Can you tell me what type of reaction is this? And good, you guys, some of you have tried the next one also. We'll come to that. So what category based on your types of chemical reactions does this fall into? So somebody is asking, what is the meaning of corrosion? Corrosion means the surface gets eaten up, right? Like we say, when rusting happens, the iron gets corroded. So the surface that gets eaten up, so acid can actually eat up the surfaces like plastic, skin, right? It just goes and reacts it and removes the surface, right? So that's the rough meaning of corrosion. Excellent, I see the right answer. This is a simple displacement, or what is known as single displacement. Now, what is happening here? Why is it called a single displacement reaction? So this one, let's write that. So this is a single displacement, right, reaction, or simply displacement reaction. And why is that? Because the metal zinc is displacing out hydrogen. Can you see? It just kicks out hydrogen from sulfuric acid and takes its place there. And so hydrogen comes out. So this is known as a single displacement, where the reactivity series comes into play and a more reactive element displaces a less reactive. So it just tells hydrogen, you get out of sulfuric acid, I'm going to take your place. So it's going to be zinc sulfate and hydrogen. Similarly, let's apply this for magnesium and dilute hydrochloric acid. So the next one, so what do you think is going to be the answer of the second equation, guys? So Mg plus HCl, it's going to be again the same thing. Can you see? Single displacement. So magnesium kicks out hydrogen. Okay. So it removes hydrogen from here. So it's going to be Mg. So will it be MgCl or MgCl2? MgCl2. Very good, because it's based on valency, right? Magnesium has the valency 2, and then hydrogen is going to come out. Okay, very good. And so this is our salt. And guys, is my equation perfectly correct? Do I need to do something, or is the equation good to go? Okay, so guys, what do you think? Will you give full marks for my equation? Mg plus HCl gives us MgCl2 plus hydrogen. Great, you guys are great teachers. So you caught the thing. It's not balanced, right? So excellent. So please remember in chemistry, and I remember I used to walk into the exam reminding myself to balance the equations, right? So keep telling yourself to balance, and here you can see we need to do plus 2 HCl. Excellent, guys. So can you see that a metal, when it reacts with an acid, the metal displaces hydrogen. So if it's more reactive than hydrogen, it will displace it, and we get the salt and hydrogen. Now let's take a look at the next chemical property, where we say that acids react with metal carbonates and metal hydrogen carbonates, and this is also known as, so these guys are also known as bicarbonates. So you may see this term also in some of your textbooks, and they form salt plus water, and now the gas is going to be carbon dioxide. Okay, so take a look at this, and there we can you see we've written metal plus metal carbonate plus acid gives us salt plus water plus carbon dioxide, and similar equation for hydrogen carbonate. So let's go ahead and try it out. So let's try this first equation here. Sodium carbonate plus HCl, what do you think we are going to get? Okay guys, so apply the concept here that's given. So what are we going to get when you do sodium carbonate plus HCl? Right? So let me actually show you a trick of how to predict it. One is you can use the rule here, but I'm going to show you a secret trick of how to predict this reaction. Right? So let's take a look at this first equation. So sodium carbonate, we can split it into Na plus and carbonate minus. It's carbonate 2 minus, but I'm just writing minus for now. Okay. And similarly, we can break down HCl as plus minus. Okay. So guys, follow me carefully. We are breaking these compounds into the cation, positive and negative part, cation and anion part. Okay. And now what do you think, what type of reaction is going to happen here? So when you have this cation anion business, what type of reaction takes place here? Guys, think about it. So previous one was single displacement. Which one will be this type of reaction for sodium carbonate plus HCl? What do you guys think? Neutralization. Okay, any other type that can form when you have this exchange of ions, right? So it's not a combination, It's going to be an exchange of ions. Very good. I see some of you got the right answer. It's double displacement, because you can see these cations are going to exchange their positions. So let's see what does that mean. So this guy is going to take this place and hydrogen is going to take the place here. So what are we going to get? So take a look at this trick to predict this reaction. So sodium is going to exchange places with hydrogen. So it's going to be NaCl because the valency is 1. And then we are going to get H and CO3, which is going to form carbonic acid, H2CO3. So this is very good. Double displacement or double decomposition is the type of reaction here. So let me write that down. So we are looking at double decomposition reactions in this type. So now you can connect your first chapter where you learned about types of reactions and this one. So this is double decomposition or double displacement, right? And now do you see what's happening? NaCl plus H2CO3. Now one very important point, carbonic acid is unstable, right? So it's not going to stay as carbonic acid. This guy is going to break down into, so I'm going to erase this. So carbonic acid is going to break down into H2O plus CO2. And that's how carbon dioxide is produced. Okay, guys, because carbonic acid's H2CO3 is unstable, so it breaks down into these two guys. Okay, and so with this help, see, we've predicted our reaction. And the last thing we've got left is to balance it. So let's quickly go ahead and balance this equation. So that's 2 here, right? So I think our equation is balanced now. Excellent. Now let's take a look at the next one. Again, let's use our secret trick to try to predict this, right? So what can we do here? So we need to break these compound in, because we know it's a double displacement reaction. So let's break it down into K plus and the hydrogen carbonate ion or the bicarbonate ion. And similarly, we'll break HCl into plus minus, right? So this is a very useful trick for you to understand what's happening. So then you won't have to learn these reactions. You can simply predict it, okay? So it's going to be really useful for you. And you can see that these guys are going to exchange their positions, okay? And so what are we going to get? It's going to be KCl plus H2CO3, right? Again, and remember, H2CO3 breaks down into H2O plus CO2. Okay, so don't leave it as carbonic acid. That's not going to be completely correct. And so you're going to get this, and I think the equation is already balanced. So we get the salt, in the first case was sodium chloride, the second case is potassium chloride. Okay, and then we get carbon dioxide gas. And guys, do you know how to test carbon dioxide gas? So how do you test the carbon dioxide gas that is produced? Do you guys know that? So we've got carbon dioxide being produced here. So how do you test carbon dioxide? What is the chemical test to test it? Very good. I see the correct answer. Lime water test, right? So a lot of you are writing lime water test in the chat. Excellent. Because you know that when carbon dioxide is passed through lime water, it turns the lime water milky. So this equation can actually be used to test out acids. Okay, very good. Let's take a look at more properties of acids. So this is a famous property where you must be knowing that acid and base, right, react to form salt and water. So take a look here. And we also say it could be a base or an alkali. So guys, do you know what is the difference between base and alkali? So if you look at this equation, we are saying acid plus base reacts to form salt and water here, right? So what is the difference between, so acid can react with a base, or we can say, or it can react with an alkali. And very good, I see some of you are writing the correct answer. The definition of alkali is very simple. Those bases, so let me write it here. Alkali means those bases that are soluble in water. So bases that are soluble. So bases that are soluble in water. Okay. So you need to know this, right? The definition of alkali, because not all bases are soluble in water. And good examples are, so from this list, can you tell me who are the alkalis? So it's going to be sodium hydroxide here is an alkali and potassium hydroxide. Okay, these are the alkalis here. Copper oxide is not soluble in water, and so this is not an alkali. So this guy is not an alkali. Okay, so you need to learn the list. sodium hydroxide, potassium hydroxide, ammonium hydroxide. These are all alkalis. Okay. Now let's take a look at this important question. What is this reaction called? Excellent. I see a lot of correct answers. So you've given the answer already. Superb. This reaction, famous reaction in chemistry, acid plus base gives salt plus water, is known as neutralization. Right? So neutralization reaction. Okay, so it's called a neutralization reaction because we say the acid is reacting with the base to form salt and water. It's neutralizing the base, or the base is neutralizing the effect of the acid. Okay, that's why it's called a neutralization reaction, and it's a really important reaction in chemistry. So now let's take a look at the first reaction. So when sodium hydroxide, so this alkali reacts with hydrochloric acid, what are we going to get, guys? So can you try the first equation here? So NaOH plus HCl, what are we going to get? And yes, that's right, neutralization means to cancel the effect of. So acid cancels the effect of the base, or we can say the base cancels the effect of the acid. Excellent. And a lot of you have got the correct answer. So the first one is going to be simple, sodium chloride, right? The salt that we eat, plus water. And again, this reaction neutralization fits into which category? So if you break this ions, plus minus, can you see? Right? So Na is taking the place of hydrogen. It's going to give NaCl plus water. So can you see that in these cases, double displacement is happening, right? So it's of the type double displacement. But it's given a special name because it's such an important reaction in chemistry. So we call it neutralization. Excellent. It's a double displacement. So guys, really understand these concepts and then you'll enjoy the equations in chemistry. Don't just learn them up. When you're looking at an equation, try to analyze why it's happening. Always try to predict the answer. Then you won't have to learn most of the equations. Trust me, you'll find it much more interesting. Same way, let's see if we can predict the next one, right? So we know that KOH is a alkali, sulfuric acid is a base, sulfuric acid is an acid, KOH is an alkali or a base. So what is the reaction going to be? So here we split it up into potassium and hydroxyl ion, and here it's going to split into, again I'm not writing the balance here, just splitting it into plus minus, right? And so when it combines with KSO4, so it's going to be K2SO4, not KSO4, because sulfate has a valency of 2. So again double displacement, and you're going to get plus water. So this is the salt that is formed. Can you see the salt here? Same way the salt is here. So sodium chloride is not the only salt. Potassium sulfate is also called a salt because it contains a cation and an anion, right? Potassium ion and the sulfate anion. Okay, so guys, can you try to predict the next one where copper oxide is a base? It's not an alkali. So guys, can you try this one? What will be the answer for the last one? When copper oxide reacts with hydrochloric acid, what are we going to get? So please try it. Oh, good. So some of you are saying, I think I forgot to balance the previous reaction. So do remember, good, because there should be 2 over there, right? And this thing, and now I think the equation is balanced, right? And we'll get 2 water. Okay. So guys, please do remember to balance your equation. Very good. So you guys are highly alert in the chat. Excellent. And can you guys predict what will be copper oxide plus HCl? Okay. So that copper oxide is also known as cupric oxide. It has the valency of 2. So let's again try and see what's going to be the reaction here. So let's split this into plus minus, right? And a plus minus here. So we're going to do a double displacement here, right? And guys, we're going to get CuCl2, because copper had the valency of 2 on the left. It's going to carry the same valency. It's not going to be CuCl plus H2O, right? And then again there's going to be a 2 here. Okay, so somebody is saying there'll be no reaction. No guys, that's not the right answer here, because that's for single displacement. In double displacement, it's just an exchange of ions. So copper is not displacing hydrogen here. Okay, so don't consider this as a displacement in the sense of a single displacement. It is called double displacement, but it's actually an exchange of ions. So we can't say is copper below hydrogen or is hydrogen below copper. Both of them are doing an exchange. So the reaction will certainly happen and you'll get this salt and water. So this is our salt here, copper chloride and water. And guys, do you know what is the color of copper chloride? So an important observation. So what's going to be the color here? So there is going to be a reaction in this case, as you can see, because it's double displacement. So don't apply the single displacement concept of reactivity. Very good. I see a lot of you have got the right color here. So let me write that. So the color is normally known as bluish green, right? So it's a blue green, or some books just write blue or green. Some books write blue green color. So that's the color of copper chloride. So it will be a blue green solution. And what's the observation? This guy, copper oxide, is actually black in color. So the black color thing reacts with hydrochloric acid to produce a blue-green solution. So see, based on the equation, you can predict your observation. You just have to learn up the colors. Okay. So this is an important thing for you to know, that just learn the colors and predict your observation based on your equation. So now we talked a lot about acids. So one important thing is, what do all acids have in common? So I've given a fill in the blank for you here. So all acids contain dash. So can you fill in the blank for me? Okay, excellent. I see the right answer. All acids contain hydrogen. So that's really important. Hydrogen is the king here. Hydrogen must be present in each and every acid. You cannot have an acid without hydrogen. Okay, guys. So please remember this important point. Okay, and now let's look at another important point, that acids show their acidic behavior only in the presence of water. So hydrogen must be present in the acid, of course, and water also needs to be present, and we'll see why. So let's take a look at this important equation. So here AQ, what does AQ mean? So AQ means aqueous, right? So it's in the presence of water, right? And so when you have hydrochloric acid or hydrogen chloride, we say, right? So HCl, or once it's in solution form, we say hydrochloric acid. That's going to break down in the presence of water into these ions. Okay, so please take a look at this very important equation, and this is called an ionic equation, because can you see there are ions formed on the right hand side here. Can you see that, guys? So hydrochloric acid breaks down into H plus and Cl. So this is called this is the hydrogen ion, and this is the chloride ion. Okay, right? And this hydrogen ion is very important, because this is the guy. So this hydrogen ion is what causes the acidic behavior or the acidic nature. So you must have H plus ions for an acid to show acidic behavior. So if you don't have water, if it cannot break down, if it cannot dissociate into hydrogen ions, it cannot show its acidic behavior. Okay. Now there's one important thing, is hydrogen ion, what is is that the ion present in the solution? The answer is actually no, because please understand this important point. In reality, this hydrogen ion H plus, okay, actually combines with a water molecule to produce this very important ion called H3O plus. And do you guys know what is H3O plus known as? Excellent, I see the right answer. So it's hydronium ion, right? So please learn the spelling. So so in reality, look here. So this what we've got here in this equation is just a simplification. So this is our simple form of the equation, where we are saying, okay, HCl breaks into H plus and chloride minus, but in reality the H plus then combines with water to form hydronium ions. So let's write it directly in the second equation. We're going to write it clearly, that when HCl reacts with water, okay, it's going to produce, so that H plus will combine with water. So a reaction is happening with water, and it's producing H3O plus plus chloride minus. So this is our more complete or actual equation. So what's happening in reality? So guys, please take a look at this. Really important. This is a very important concept in the acid chapter. So if you understand this, then you'll understand the main concept in the chapter of based on this ion thing, right? So take a look at, I've written two equations for you. As I said, the first equation is the simplified form, right? So you might find this in a lot of textbooks where they're just simply writing, okay, water dissociates or breaks the acid into, it tears it apart into H plus and chloride minus ion, right? Can you see that, guys? So, but the hydrogen ion and the chloride ion, but the hydrogen ion is not the reality, okay? So it's really, when it combines with water, it is this hydronium ion that's formed which causes the acidic nature. So it is this guy which is causing the acidic nature. And that's why the reality is this equation where we say HCl plus water, right, forms H3O plus chloride minus, and that's our hydronium ion here, right? Hydronium ion. Okay, so usually if you're being taught hydronium ion, you need to write this the second equation. If you're being taught in the simpler H plus form, you can write that. Both are showing the same concept, but one is a simpler form. Okay guys, so please really understand this, and this really important point that water, right? So water is essential for the acid to show its acidic behavior. So water is also very important. Otherwise the acid will not show its acidic behavior because it will not be able to produce the hydronium ion. Okay. Now let's take a look at some more acids. So let's apply the same concept. So just like we applied it for HCl. So guys, you should know how to write these ionic equations for some more acids. So what is the first acid here? Can you see? The first acid is nitric acid. Okay. So what is it going to be? Nitric acid, water is going to tear it apart again, right? So water, or you can consider water is in our, you can write it on top of the arrow because it's not participating. So it breaks it down into H plus and nitrate ion. Okay. And this is our simple hydrogen ion here, right? Okay guys. So water is breaking it into H plus and nitrate ion. And in the next equation, you can see we'll try to write the complete equation where basically what is the concept? That this H plus is basically going to combine with water. So it's like a second step, right? So H plus will combine with water. So instead of H plus, we just have to write H3O plus, okay, and plus nitrate. So guys, if you take a look at the equations here, they are pretty much the same thing. The only difference is we've added water for this guy. Can you see that? So it's pretty much the same equation. The first is the simplified form as we discussed. So this is the simplified version and this is the actual form. Okay. And if you're being taught the hydronium ion, please write it in this form, right? This is our hydronium ion. Now guys, try the next one for sulfuric acid. Okay. So let's take a look what it's going to be for the next guy, sulfuric acid. So again, here we can say H plus and sulfate. You need to write the correct valency this time because it's an ionic equation. We're expressing 2 minus. Now, is this equation completely correct? Is there any issue here with my equation? So please take a look for my sulfuric acid equation. This equation, is my ionic equation completely correct, or do I need to do something here? What do you guys think? H plus and sulfate. Okay, somebody says I need to balance it. Yes, you need to balance these ionic equations. And you don't have to worry about the charge plus minus. Again, same thing, just balance the atoms. So on the left side, how many hydrogen atoms are there? 2, right? And on the right, there's 1. So we need to multiply by 2 here. So sulfuric acid, when it breaks down in water, so in the presence of water, 1 molecule of sulfuric acid is producing 2 H plus ions. Nitric acid or HCl was producing 1 H plus, here it's producing 2. So now you can see the equation is balanced and the charge is also balanced. The left hand side, the charge is 0, it's neutral, and the right hand side, it's 2 plus and 2 minus, right? 2 into 1 plus and 2 minus, so that cancels. Okay, and now how to write the actual equation? That's also pretty simple. You can just apply the same trick here. So just copy the same thing, 2, and instead of H plus, we are going to write H3O plus. Okay, and sulfate is going to be the same thing, sulfate with valency 2 minus. Don't write minus 2. In chemistry, we write the number first. Okay, and is there anything else I need to do? Is this equation balanced or something that I need to do here, guys? Right? So to balance this equation, we need to do 2 water, because those 2 H pluses are going to use 2 water molecules to convert into this. So this is our simplified form and this is the actual form. This is a very important. If you understand these ionic equations, then believe me, this part is going to be really easy for you. So please just follow these slides. I've shown you 3 examples, really important ones: HCl, hydrochloric acid, and nitric and sulfuric acid. And I've shown you the easy way. Write the simple equation and you just need to add water or just convert the H plus to H3O plus. Okay. So now we have this, remember we talked about this classification that acids can be classified as strong or weak acids. So now we have this interesting question that what makes an acid strong or weak, or why is an acid strong or weak? Okay, so here you can see that let's take an example. So can you see here that in the strong acid we have this guy HCl here, right? Can you see, guys? So in the strong acids we have HCl here, and in the weak acids, let's say we have acetic acid here. So I'm going to write the equations. So if you take HCl, right, and I'm going to write the simplified form for now. So in the presence of water, it's going to give us H plus and Cl minus ion, right? And if you take acetic acid, the formula is CH3COH as we discussed, and in the presence of water, so let's write water on top here, it's going to break down into, so acetic acid is going to break down into CH3CO minus and H plus. Okay, so can you see that both these acids, HCl and acetic acid, can you see one molecule of the acid is giving an H plus, right? Let me just write this clearly. So it's giving, both of these guys is giving, one molecule is giving one H plus. So guys, can you tell me then why is, we know that hydrochloric acid is a strong acid, right? It's a mineral acid and it's a dangerous strong acid, but acetic acid, vinegar we eat. So guys, can you tell me why HCl is a strong acid, but acetic acid is a weak acid, even though they are producing one H plus per molecule? What do you guys think here? So this is a very important concept, right? So pH, yes, pH is one way to test it, right? But the pH of HCl is going to be lower than acetic acid. But what makes it a strong or weak acid? Mineral and organic acid is a classification. That's not the reason. So the main thing here is, so please take a look, that when HCl it dissociates in water, for example, let's say there were 100 molecules of HCl, okay? And let's say they are going to produce 98%, it's going to decompose into H plus. So this reaction will happen under 98% basis. So we started with this thing. So let's say there are 98%, it dissociates into H plus and Cl minus, right? But if you take a look at acetic acid, let's say we started again with 100 molecules and it's only going to dissociate 20%, right? So what is the main difference here? The strong acids, they dissociate almost completely. So they produce a high concentration. So these guys produce a high concentration of H plus, or we can say hydronium ions, right? And these produce a low concentration because they don't dissociate completely in the presence of water. Even though both are acids, this is their nature, that HCl will, so if you take 100 molecules, 98 of them are going to split up into H plus and Cl minus. So you will have a high concentration of H plus or hydronium ion. And you know that H plus or hydronium is what causes the acidity. So that makes it a strong acid. But in the case of weak acid, only 20% or maybe 10, 15% it dissociates. I've just taken these rough numbers as examples, and that's why it's a weak acid. So this explains you what makes an acid strong or weak, okay? How much it dissociates, or what is the concentration of the hydrogen ion. Clear? So this is a really important point for you to know. And guys, I have an interesting question for you. So the question is, glucose and alcohol, right? They contain hydrogen, because you know what is the formula of glucose? So glucose, the formula is, guys, what is the formula? C6H12O6, right? And alcohol, the formula is C2H5OH. So can you see these guys contain hydrogen, but we know that they are not acids. So these guys are not acids, right? The question is why? Okay, right? So these guys are not acids, and glucose and alcohol, and you need to tell me why, and I'm looking forward to your answers. So do write your answers in the comments below and I'll reply to them as soon as possible. So this is a homework question for you guys to try and think about, right? That glucose and alcohol, they contain hydrogen, but they are not acids. So go ahead and try this question based on the concepts that we've learned, okay? And do write your answer in the comments below. I'm looking forward to reading your comments. And guys, another homework for you. So I have this video covering the basics of acids, bases and salts. So you can just search for acids, bases and salts, Manocha Academy, and do check out this video. I've discussed the practical aspects and I've compared all these three categories and I've shown you the tests of them. So I think you'll find it really useful. So do check it out. And as I mentioned earlier, we have our website manochaacademy.com. So do check out. We have the physics CBSE class 10, class 9 course, the ICSE class 9 course, and soon we'll be adding our chemistry and maths courses. So guys, please check it out, and thanks a lot for your support. It's great to read your comments on our YouTube channel. So Manocha Academy is our YouTube channel, and if you haven't hit the subscribe button, do hit it right now and click on the notification bell so that you don't miss out these live classes. I'm trying to take live classes every day right now, and so please go ahead and click on the notification bell and share out our videos and with your friends so that more people can benefit from these. And I thanks you a lot, and you've been really interactive in this session. It was amazing to see a lot of comments and answers. You guys did great. I'm really happy to see that. But don't forget to try out this homework question that is there for you. Write it in the comments, and do check out this video on acids, bases and salts. And we have many more physics, chemistry and maths videos for you to check out. And here's our website, which has the complete course. So guys, thanks a lot. I'll sign off here and take care. Bye everyone. It was a great session with all of you. Thanks a lot. Bye.